Okay, so in the last video we looked at the introduction of collisions between two spheres, and we looked at the first part of Holden's worked example 7.4. So in this video I'm going to look at parts 2 and parts 3. So what did we find out in the last video? Well, we found out the final velocity of each sphere after impact. So this was our kind of table at the start, and what we found out was that P was equal to 1, so the velocity of sphere A after the collision was 1. And Q was equal to 7. So now we know P and we know Q. Next part is find the impulse imparted on each ball by the impact. So you might remember from the last video the equation for impulse is mv minus mu. And we have to do this for each ball. So let's do it for ball A first. The first ball, why don't I write it over here? Impulse for A is going to be the mass of A times its final velocity, so the mass of A is 2 times its final velocity, which is 1. Take away the mass of A, multiplied by its initial velocity, which is 10. Now that's going to be 2 minus 20 is minus 18. Now we could include the direction here, so we could say I as well, because we're traveling in the I direction, meters per second. Sorry, not meters per second. The units for impulse is Newton seconds, capital N, small s. So that's the impulse on A, and the impulse on B then is going to be its mass, which is 3, times velocity, which we figured out is 7, minus its mass, which is 3, times its initial velocity, which is 1, and that's going to be 21 minus 3 is plus 18 I Newton seconds. Now it's not just a coincidence that they're the same number except different signs. What this is basically a measure of its change in momentum in that direction. And I know we haven't spoken much about momentum, but I'm just kind of doing enough for you to keep kind of moving on with the questions, and we'll come back over all of this next year. But what you'll find is these will always be the same number with opposite signs. So if A exerts an impulse, or if A has an impulse exerted on it of minus 18I, B will be plus 18I. So that's part 2 done. So it's really easy once you know those equations. Next part is the total loss of kinetic energy in the system. So again, from last lesson, you might remember that kinetic energy is equal to half mv squared. And if we want the total kinetic energy loss, it's going to be the total kinetic energy before, sorry, the pens are gone terrible, minus the kinetic energy after. Because if kinetic energy is being lost, then there must be more kinetic energy before and then less after, so the difference will be the difference between two. So what I do is I find them out separately. What's the kinetic energy before? Well, before there's two things moving. It's going to be the kinetic energy of sphere A plus the kinetic energy of sphere B. And be careful, it's before, so we're only looking at this section here. So it's going to be half mu squared for A, u because it's the initial velocity, it's before, plus a half mu squared for B. So that's a half mass of A is 2 times minus 10 squared, plus a half mass of B is 3 times minus 1 squared. Type that into your calculator and you should get 101.5 joules. Then you find kinetic energy, Ke after, and it's the exact same, but this time it's going to be half mv squared for A plus a half mv squared for B. So that's a half the mass of A, which is 2. The final velocity of A, we got v1 squared, plus a half B was 3, and its final velocity was 7 squared. I know this pen isn't working very well, but you can kind of listen as I go along and hopefully it makes sense. And when you type that into your calculator, you should get 74.5 0.5 joules. So now the kinetic energy loss is after, so it's going to be 101.5 take away 74.5. So the kinetic energy loss is going to be 27 joules. So there's a lot of new kind of equations in this, but it's just making sure you're familiar with the equations, and we go over them in more detail in the future, and if you do physics you go over them in more detail as well. But as I said, I just want you to kind of learn the equations and then work through the questions, and you can improve on that kind of as time goes on, or you can improve your knowledge on kinetic energy and momentum as time goes on.